Question number 7. We have this parabola. B can be any positive real number. No, any number. B can be positive or negative. Find the values of B, which the two solutions have a difference of 5. Okay, so I'm going to use the quadratic formula to find the solutions. So x is going to equal minus b plus or minus the square root of b squared minus 4 times 1 times negative 6 all over 2. So x equals minus b on 2 plus or minus a half square root of b squared plus 24. Okay, so the difference between the two numbers will be two lots of those. So 2 times a half square root of b squared plus 24 has to equal 5, because I've got minus b on 2 plus a half the square root or minus a half the square root. So therefore, two lots of these will be the difference between the two numbers. So that's the square root of b squared plus 24 equals 5. Square both sides, b squared plus 24 equals 25. B squared equals 1. B equals plus or minus 1. So that's the answer to A. In B's case, let B be negative. Okay, so if B is negative, then I've got a parabola that looks like, so I've got x squared plus bx minus 6. And if b is negative, that's going to drag my turning point to the bottom right. So my parabola is going to look like this. Explain why the inverse function does not exist when f is restricted to the domain 0 to infinity. So if I was to restrict the domain, then my graph is going to be many to 1. If k is less than 0, turning point is an x value that is positive, because minus b on 2 will be positive because b is negative. Therefore, f is many to 1. So the inverse is 1 to many, therefore not a function. Okay. In part 2, find the rule for the inverse when it's restricted to this domain and it's negative infinity to 0. So when it's looking like this, because b is still negative, because part 1 and part 2 are both indented, so b is still negative. So that's negative 6. When I look at my inverse function will come from negative 6 and will look like that. So I want the negative square root when I get to work out the negative square root. So y equals x squared plus bx minus 6. Is that right? Plus bx minus 6. I'd like to complete the square. So y equals x squared plus bx. A half of b is b on 2, so plus b squared on 2 squared, which is 4, minus b squared on 4 minus 6. And that becomes y equals x plus b on 2 all squared, minus b squared on 4 minus 6. I'm going to swap them. x equals y plus b on 2 all squared minus b squared on 4 minus 6. Or x plus b squared on 4 plus 6 equals y plus b on 2 squared. Taking the square root of both sides, I want the negative square root of x plus b squared on 4 plus 6 equals y plus b on 2. Therefore, the inverse rule will be, when this moves over, negative b on 2 minus the square root of x plus b squared on 4 plus 6. You could, if you wanted to, say you had 4x plus b squared plus 24 all on 2, taking it out of the square root. I'm going to leave mine like that. Over the page to part C. Let G be the function of domain of the rule of this. So G of x equals log base E of minus x minus 2. Find the value for B, which is the maximum domain of the composite G of f. So therefore G of f of x. And we want that domain to be that. So I'm putting f of x inside G of x. So G of f of x is going to equal log base E of minus x squared plus bx minus 6 minus 2, which is log base E of minus x squared minus bx plus 4. And I want the domain of this, so the domain of fog, goff, equals the domain of f, which is this one here. And I want that to be between negative 2 and 2. So I'm looking for the inside of the logarithm, minus x squared minus bx plus 4 has to be bigger than or equal to 0, given the x values from negative 2 to 2, because that's what I've been told the x values are. So, I've got minus x squared plus 4. That looks like this. And that's going to have x-intercepts at negative 2 and 2. So I actually don't want this to exist, because when it's between negative 2 and 2, that's positive, and I can take the square root of it. So I want b is equal to 0. Because the minute b becomes a positive value, then that's going to move my turning point, and my domain is not going to be negative 2 to 2. So b equals 0 is the only way that that can happen.